Hey everyone! Thank you so much for watching another episode of the Weaviate Podcast. I'm super excited to welcome Charles Packer, the lead author of MemGPT. MemGPT is a super exciting new research paper framing the operating system for large language models. We've done a paper review video on Weaviate YouTube, and it's already one of our most successful paper summary videos already, and the ideas are just so exciting. So I couldn't be more excited to interview Charles. Thank you so much for joining the podcast.
Awesome. Yeah, thanks, Connor. Happy to be here.
Awesome. So could we this large language model operating system, could you set the stage on what inspired you to start looking into this?
Yeah, I'd say it started mostly with a focus on chat. So it was more about like how people are using large language models for chat purposes, and fundamentally like how memory was basically just limiting how people were using these chat applications or chatbots. So with like ChatGPT, very common pattern I noticed, at least among Berkeley power users, is that you have like a million chats, and the chat history windows basically become useless because every single new task someone wants to do, they open a brand new chat window to do it. And a lot of it is it's like muscle memory, because we've kind of noticed as users that over time the chat quality degrades. You kind of just go in circles, and you're better off just like starting from scratch. And it's a similar thing with like maybe character AI or like these entertainment chatbots, where I don't think anyone's really under the impression that they're going to chat with these bots for more than just a single session. The idea is that you're just going to chat with it for a little bit, have fun, and then throw it away. And it's not like you're picking up where you left off from. But I don't think like the designers of ChatGPT or Character intended to build these things this way. It's really just a limitation of the models that they're using, right? Like transformers just have fundamentally a limited context window, and to get around, you can do a lot of engineering to get around it, but you're not going to like fundamentally change the model to get around it. So if your model is really great, you can build a really great chatbot like how Character has or OpenAI has, but you just can't go past I don't know, like dozen, hundred most messages back and forth. So yeah, that's really where MemGPT started. It was trying to get around this like memory problem with LLMs.
Amazing. And yeah, I guess just kind of transitioning to the kind of the solution, this explicit memory management, having a prompt that says, hey, you only have 4,000 tokens. What's important for the working context? Can you kind of describe like how that idea came to be?
Yeah, I'd say so. Practically speaking, it came about. I guess we've been working on this for a while. So when I built the initial version of MemGPT as a chatbot over the summer, I think the whole memory self-aware memory editing thing came about partially because functions came out at the same time in the OpenAI API, and I think I've been really like racking my head around these like memory ideas and how to handle them properly for a while. And then when functions came out, um, it wasn't immediately clear that you could use functions for this purpose, like self-editing your own memory. But I tried it out, and I remember it working kind of off the bat. Like immediately, I was like kind of shocked at like the first pass of this idea actually was working reasonably well. Um, but I will say, like broadly speaking, I do think the way MemGPT does function editing, or it handles memory, which is uh, very meta. It's like very self-aware, right? I think this is kind of following trends in language models as a whole, where it used to be that people did a lot of like prompt hacking, prompt tuning, a lot of kind of crazy shim code, plumbing code to get things to work with prompts. And now you're just seeing the models are getting better and better through RLHF and instruct tuning, that people just are converting their old code into natural language, and they just put it into the prompt. You just tell GPT-4 what you want it to do, and it does it better than if you tried to like do some crazy prompt to get around to like do it implicitly. And MemGPT is very much like in that direction, where you could write a ton of code to handle memory and to handle context behind the scenes, but you could also just tell GPT-4 or whatever model you're using off like straight up that it has memory limitations, and just like be aware you have memory limitations, and you can write your own algorithm given like a core set of functions on how to manage your own memory. It's up to you. But yeah, I think that meta idea is very much in line with like the way things are going with LLMs, where you put the programming into you take out the programming and you put it into natural language, and you just let the LLM do what it wants.
Yeah, so if we could, in the memory management tool, so you have APIs to append to the working context as well as to write to the vector database. So these, or the database, obviously biased with Weaviate,
Yeah.
vector database.
Yeah.
But like, is this kind of the general, like, is this the correct understanding that you have the kind of the operating system where you have the system message that says, hey, we just got to 4,000 or 3,000 tokens, and then in that kind of OpenAI Funcs approach, where it has this dictionary that's saying, here's the append function, or the remove, or maybe like almost like a flush to disk kind of thing, right? With
Mhm.
writing to memory. Is that just kind of like is it the correct understanding of the?
Yeah, that's exactly kind of what's going on. So to kind of make the LLM more self-aware, you kind of like raise the level of abstraction, and you now it's no longer like with traditional language models and chatbots, even like the way you code them, it's still very much user input goes in, agent message comes out, and it's got a one-way street or it's a two-way street, and it's a one-hop operation.
Hmm.
I think LangChain, there's a lot of like I guess you call like chains that they have that do involve multiple hops, but it's still generally speaking like this high-level idea of user message in, agent message out. And with MemGPT, it's no longer user message in. It's like a system message, a high-level computer OS message that goes in. And the OS message can contain a user message in it. It'll just be a little JSON thing that says this, the type of this message is user message, and the content is this. But then we also are using those system messages, those OS messages, to send alerts that are very meta, like you are running out of tokens, or your attempt to try to reorganize memory failed because you addressed the memory wrong, something like that. But yeah, your general understanding is correct. Yeah.
Yeah, I love that idea. I think it's such a novel thing to have that explicit kind of separation of system messages, and I guess maybe kind of jumping ahead of the topics we kind of as we prepare for
Yeah.
these podcasts, but like this kind of like the sort of concept of like interrupts that you've introduced into this kind of it's quite different from most retrieval augmented generation, where you're just kind of retrieving to put in the input. Now you have this whole like event processing, whether it's entering a message or if it's the system message of you have 3,000 tokens. Then there's also kind of this idea of you uploaded a document, and now that kind of triggers some processing, and maybe it's asynchronous and there's like interrupts. So if we could dive into interrupts, I think the reason why it would be nice to kind of do this early in the podcast is because it just really, I think for me, brings this like operating system for RAG home, is adding that kind of asynchronous background processing.
Yeah. So as you were saying, like we kind of were just calling interrupts like any sort of honestly like any message that's not a user message. It is kind of an interrupt because it just triggers the LM to get run, right? And in like a more like RAG setting, I guess I'll just say like a data setting, not just chatting, but like you have some data that you're trying to do something with. Um, there's all sorts of interrupts you can imagine. Like generally, I think RAG is a super broad term now. It no longer just means like retrieval augmented generation, but in the RAG space, I think my understanding is generally speaking, you embed the data and you put it in, and then you ask questions. That's and often like the chatbot is not even aware that like there was this uploading that happened. It's more that it just gets shoved into the context with maybe like a nice little prefix or something. But with MemGPT, it's very much I think the way you can like turn MemGPT into very much RAG. But I think if you were trying to build it out in like more of the MemGPT mindset, it would be very much like you can upload whenever you want to some data store, and the data store will send out alerts to the MemGPT saying like an upload started, an upload finished. You can find the upload here. And now MemGPT always has the tools to kind of like access the database, and those tools can be as simple as just like a read that has a very specific line number or something, or as simple as just a search with a query, and that query is getting put into like cosine similarity on some vector store. But it can also be like an extremely complex RAG workflow that you saw on Twitter that has like 10 different nodes covered. You have to like zoom in on your phone to see like all the details. You can't put that behind a tool that MGPT can use, right? Like MemGPT it's the way to think about it is it's more like just like an agent a tool using agent, right? So it's less about like it's always like very self-aware of what exists. It's kind of like if you just had a human in the loop, like the human is using tools to look at data. They're not like there isn't some injection that goes into your brain that like front loads little context windows and you're unaware of it, right? You are very aware of like kind of what you're doing with the flow of data.
Yeah, really, I'm seeing a lot of like RAG evaluation things, and like at Weaviate, we just released an async indexing API. So it kind of has this
Mm-hmm.
API of like, it's still indexing, but you can query it. And it kind of like reminds me of like maybe you're training a model in the background and it's like, ding, that model you're training, it's ready if you want to,
Yeah.
and that kind of meta management of the tools is so interesting. So maybe if we could step further into your perspectives on tools. I know, we had Shashir and Tianjin on the podcast, and I'm such a fan of the Gorilla work. And my understanding, Shashir is on the MemGPT paper, and I
Right.
imagine you'll work closely together. How are you currently seeing the kind of LLM tool use landscape?
Yeah, I think so. I will say, just at a very high level, I think tool using agents is where everything is kind of trending towards. I think that is going to like. I'm actually very surprised that like function calling has not become somewhat standardized in OpenAI endpoints. So a lot of people like support OpenAI endpoints, but like no one is really standardized on like the equivalent of OpenAI functions, right? Where you just pass in functions as the keyword argument. Um, so it support's like really lacking. And the reason I'm surprised is because I really do think this is like where everything is trending. Everything is trending towards tool using agents, even if you don't necessarily think of your agent as having to use tools like a chatbot. I think it still will like trend in that direction. Maybe more specific to Gorilla, I think there's really cool ways where like ideas like Gorilla and MemGPT kind of overlap. So like with MemGPT, and a pretty big, it's not really a limitation, it's more like a design trade-off, is that you're giving it tools, but obviously you have to like tell it up front what the tools are. And if you don't fine tune on those tools, you have a big chunk of text that has to get inserted with every single inference call. And with MemGPT specifically, I think the pre-prompt is around 1,000 tokens, roughly that, like 1,000, 2,000. Which if you're using like GPT-4 8K, like Mistral with approximately 8K context window, that's a huge chunk of your context that's getting devoted just to like static information that never really changes. So you can fine tune to be like more MemGPT specific and hopefully take those tokens out. But I think maybe a more promising direction you can go in is your MemGPT agent. It doesn't call functions in function space. It calls functions in natural language space. So it will basically say like if it wants to move data back and forth, it gets an alert or something, it'll call like an abstract function or even just say something in natural language like, hey, I want to clean up my core memory and I want to flush it out. And then that will get passed like a Gorilla or something, which can be updated much more frequently to include like all these new functions. And now it's kind of the best of both worlds, right? Like your main MemGPT agent is very self-aware, it's very meta, it knows that it's context limited, but it doesn't also have to manage that. That's already a lot to manage, like this meta information about like that you're a limited context transformer. And it's a lot more to then also understand all of memory management functions, know the correct parameters, how to run them in a chain, basically. But if you can just offload that to like a Gorilla, then you make the process a lot easier for like the main MemGPT thread. And I think that's probably, if we build out MemGPT v2, that is what it will probably look like. It'll look closer to like Gorilla plus MemGPT than just MemGPT handling all the functions.
I think it's such an exciting direction. I mean, like the kind of like describe your tool in as few tokens as possible, but it also sounds like you're looking into this kind of like in the same way you're rotating in your context, you might want to rotate in what tools are being described in the system instructions. And yeah, well, I think that's a really profound direction. I guess kind of I think this would transition really nicely into kind of the fine tuning of MemGPT. Like, so for me, the thing about Gorilla that I think is also really really interesting is that it's like if you want to use SQL as a tool, you also have this fine tuned language model for text to SQL in the middle of that, and then that model can be like. I don't know what the smallest state of the art text to SQL is because it's like such
Yeah.
a fast, but I think they're at like 15 billion is like the state of, but like the idea being you can compress it to use it. I know like our Weaviate Gorilla is like not as big as GPT-4, but so yeah, that's kind of is the question I guess would be how you see that kind of like you have I imagine MemGPT it's like a smaller model that's managing the memory, whereas like the GPT-4 like just the most powerful thing we can find is what eventually kind of answers the question. with the context managed by this distilled MemGPT. I hope I didn't like transition to, yeah, if you could.
Yeah. So I guess is your question kind of about how you delegate like model size versus like all the responsibilities that you need or all the programming you effectively need the LM to do to manage MemGPT? Like how do you split that off into different models basically?
Yeah, exactly. So like a 1 billion parameter meta model, right? Something like this.
Yeah. Yeah, I think yeah, that's a really good question because I think ideally you want um, the main logic thread. So I would call that almost like the main LLM processor. Like that should run as quickly as you can make it run. And even a 7 billion parameter model probably might not be fast enough. You might want to squeeze that even further. But I think a 7B model, especially if it's quantized, is like fast enough. So what we're noticing with our the people in our GitHub and Discord and wherever that are playing with MemGPT with open models is that 7B actually works pretty well. I was like very surprised. So when we wrote the paper, I experimented with Ouroboros 70B, which is kind of state of the art at the time. So a huge model. Takes forever to decode on like I think I was using B100s, but so the slower than it should have been. But even a model like that, I ran into so many issues with it, just with handling all the functions and calling functions incorrectly and stuff like that. That we wrote in the paper effectively. Look, we didn't include results in the paper for this because it's just so bad. And that was like maybe 2 or 3 weeks ago, right? And then like a week after that, I kind of came back after we released the paper and revisited the new Mistral fine tunes. And I was just like shocked at how good they actually are. Like they can keep up almost with GPT-4 for a lot of stuff, right? It's a little bit like things here and there kind of like are a little bit off. Like the inner monologue, the chain of thought looks a little bit off sometimes. But these issues I was having with like 70 billion parameter Llama 2 fine tunes were no longer there with these 7B parameter fine tunes. So I'm like pretty confident that especially if you start stripping out the responsibilities for memory management out of the main thread and you give it to like a gorilla or something and you run these in parallel, you could probably have just like 2 to 3 billion parameter models running in parallel. And then you get like crazy fast decoding speed, right? Yeah, I think you can get it pretty small.
Yeah, I think that's super profound. I imagine a lot of people who listen to AI podcasts are just looking into that. Oh, the Mistral model is good, So
Yeah, yeah, yeah.
yeah,
Yeah, the hype is real. I was pretty shocked at how good it was.
yeah,
Yeah.
yeah. So I think so. The next question I want to ask about is this kind of fine tuning a specific model for MemGPT. I know Self-Instruct, that's kind of how Gorilla gets its training data. You use like the
Mhm.
large language model to generate the examples of GPT-4 is using the MemGPT prompts, and then you kind of copy the actions taken by GPT-4. Is that generally still kind of the prescription for how to get the data?
Yeah. So yeah, I think you can do self-instruct, but it's a little bit more complex than with Gorilla. So with Gorilla, right, the general input output is like question to some answer. It's almost like a Stack Overflow kind of thing, right? Um,
Hmm.
but with MemGPT, it's a long-running conversation generally that has a lot of memory management injection that's happening in parallel, kind of in this thread, and it's quite hard to self-instruct that without simulating a real conversation. Because even if you have like imagine you collect a bunch of data from some whatever websites that host like log GPT-4 chats. So you're forgetting about licensing. You don't care about the licensing. You just want to get it to work. You can like get that GPT-4 data and then annotate it backwards with like fake memory
Hmm.
management stuff, but it still doesn't quite look like the what you get with MemGPT running forward, like in a real simulation. So it's kind of like the simulation issue. I think the best way to collect data from MemGPT is you do just simulate a conversation. You have GPT-4 talk to GPT-4, or like a very good model talk to a very good model, and one of those models is MemGPT, and the other one is a fake human. Um, but yeah, it's also I'd say with collecting this sort of data, it's I at first I thought you might need a lot of it when I was looking at how bad Llama 2 70B fine tunes were. But then when I look at how good some of the Mistral 7B fine tunes are, I don't think you actually need a lot of this data. because it's close enough. And I think, yeah, you both don't need a lot of the data, and then also you might be able to get away with a lot of like heuristics on the parsing side, where you manually correct mistakes that the LM made when it generated JSON. I'm sure that's like why function calling is so clean on OpenAI's end. Is they're not just giving you back exactly what GPT-4 has spat out; they're like cleaning it with a ton of stuff. That's why you don't run into like JSON errors that often. Yeah, so just doing similar stuff to that, I think, can take you a really long way.
Yeah, I'm definitely not an expert on the structured output parsing, I think is what they call it. Things like Pydantic. We had LMQL, Luca Burek-Kellner on the podcast. And yeah, definitely some things where you can, decode only curly brackets to begin and things like that. But yeah, I think that's really profound what you're saying about the data need and the trends in that. And yeah, all that kind of facilitating the kind of compression of the open source models, knowing you need less data and all that. So I guess kind of my next question on this, the training of these specialized models is like I think I listened to Shashir on the Run LLM podcast as well, talking about like it takes like an hour on 8 V100s or something like that. I always would love to get this kind of technical detail of like how much it costs. And
yeah. I guess the numbers that we are very familiar with from the MemGPT work is OpenAI API cost numbers. And those are like soul crushing for GPT-4. So yeah, I think just to like replicate the experiments of the paper would be like just to regenerate some of the figures you made, like it's almost like several $1,000s per figure in some of the cases, just because you have to do so many GPT-4 calls. And one thing, like we made a pretty deliberate decision when we released the code. We also released this Discord chatbot, partially because that code had already been written. It just had to be refreshed. It was using the same concepts. But we made a pretty deliberate decision to only put the Discord chatbot on GPT-4, like lock the GPT-4, because at the time, and still now, the performance just with open models it just fails too often. And you have a lot of people who are just like prosumers or casuals. They kind of wanted to see like MemGPT as a peek into the future of chatbots. And we don't want to like corrupt the stream by like showing them even though it costs a lot of money, we want to show them like the real future, right? We don't want to show them like this thing that's just like breaking during errors. But the flip side to that is that it's really expensive. So like, I think we're using by default, it's going to be like GPT-4 8K, and I might be misremembering, but I think GPT-4 8K, if you hit the full 8K approximately context window when you send the inference call to OpenAI, it's going to cost like 50 cents or something. And the way MemGPT works is it's like it has this like buffer that's filling up, and it's constantly trimming off the buffer. But the smallest the buffer will ever get, usually, unless you're very aggressive with your like data management constants in the code, is going to be like 3K. So yeah, that's maybe like 20 to 30 cents or something per call. And this is just per call. And then with MemGPT, remember, it's like an OS design. So it can run a lot of calls behind the scenes just to answer one call. So you can just have conversations that are like, you're hit $1 here, $1 there. It's extremely expensive. And that's like the real cost for running this the way it looks best. But if you're talking about fine tuning, I actually don't think the fine tuning would cost nearly as much as Gorilla, because like I said, these models, like Gorilla was on top of Llama, at least initially. The models, like if you just fine tune on top of Dolphin, Mistral, or something like that, I really don't think you need that many epochs, especially if your data is clean, to just kind of do a little bit of course correction on the final outputs to make sure they're a little bit better JSON, the functions are a little bit more consistent. But I'm pretty confident you don't really need that many resources.
Yeah, it's so fascinating. I remember like Aiden Gomez talking about like large language models are like kind of like the new cloud, and hearing that big labs like UC Berkeley are the cost is in the inference call. I don't think I'm saying anything new here, but just like another example of that. And yeah, it's so fascinating hearing about the Discord and how you see that like give them the best experience versus the open source, which is cheaper. And yeah, I love that kind of talking about the latency when you have to do all these background tasks. And there's so many interesting topics, and I hope this isn't pivoting the conversation topic too much. But I wanted to also dive further into this kind of explicit context annotation. Like when I was reading MemGPT, one of the papers that ideas that instantly kind of caught my attention was this like explicit separation of the context. Like this is the system instruction, this is the chat history, and then this is the working context. And I think that's
Mhm.
quite a profound idea, because if you have, like a role playing chatbot where this is how much you have to describe your role. This is like a background information on like you work at Weaviate, it's a vector database company, like just like this kind of explicit separation of the memory. I'm curious if that's like a big thing for you, if you're really curious about further, granularizing. I don't know if that's a word, but that like
Yeah.
as it gets 32K context length, if you could see it having like 8 sections of memory, or if that's just kind of particular to the MemGPT design.
Yeah, I'll say I think when we did this initial split, like when I was coding the initial Discord bot and I split it into persona and human, I think the core working memory section, I always felt like that was a little bit uh like the bot should be able to do that itself, right? It's a little bit of like a hack to kind of lead it in the right direction. Um, so I always envision like it just being a big scratch pad and kind of in the same MGPT direction of just giving the bot freedom and like telling it, being very meta, you just telling it what the scratchpad is for, and just letting it do the rest as the models get better and better at following instructions. I think eventually, yeah, I'm not sure if you really would want to split it up too much. I think what would be really cool though is one thing that's missing from MGPT is partially because this wasn't built out as like a commercial product. If it was as like a research product, so we're trying to distill like the ideas as simple as possible to keep it very clean. But one thing that we could have put in the chatbot version is a RAG component. So like I think what a lot of people call smart context, but you have both the working memory scratchpad, but then also a separate section, like a fourth section of memory that's pinned that is also like RAG context that gets pulled from the DB all the time. And yeah, I think if you were to like take MemGPT code and you want to build out a real chatbot service on top of that, you would add that. That is something you should definitely add. You should not, and that would be another fourth part of the memory. But in terms of breaking up like the human and persona blocks even more, I you could, yeah, I guess if you're really trying to build something for pure just performance right now, like get this to work as well as possible, I have very specific demands on my application, you might start to divvy it up. I think if you're just building for the future, I think you try to keep it as general as possible.
Yeah, you brought up a point that I really wanted to clarify. So I always thought one of the most profound ideas in MemGPT is I'm parsing through the RAG results, and then I'm kind of like explicitly saying, let me grab that fact and put it in my
Mhm.
context. And then you have to
Yeah,
kind
yeah.
of, so right now what it does is it's got these 3 parts of memory, and then it's looking through the RAG is just kind of like here, and it's got these actions on how it adds that into memory. And yeah, I think you already kind of described how that might work, but
Yeah. Yeah, I mean, what you described is exactly it, basically. So for like a kind of heavy, what you anticipate will like a heavy query task. So maybe you have a question that under the hood is going to require touching like a bunch of different documents. What you do with MGPT is you prime its. I guess you could either put it in persona or user. This is why the distinction is a little bit odd when you start to talk about documents. It makes more sense for like role play or chat, but for documents, yeah, you basically somewhere in the working memory you tell it with a pinned message that this is your task and you should use the space to keep notes as you work so it doesn't get flushed out of memory. And then just like you said, memgpt will kind of make queries here and there, kind of refine its queries depending on the results it gets, page through the queries, and then slowly update its little scratch pad. And then eventually when it kind of finds the result, it can send a message back to the user with with the result that probably it kind of like collated eventually into the working memory. Um, but yeah, that's I think what you're describing, like that workflow or like the way MemGPT will actually like gather information, is maybe a good way to distinguish it from like traditional RAG pipelines, right?
yeah, and I guess the multiple documents thing, answering a question in each of the documents is like if I ask what's the Q4 earnings of ride sharing companies. I think that's what Jerry at Home Index
Yeah.
uses for that. And it's like so I can imagine it looks through the Uber search results, and then it takes the, I don't know, 30 billion. I have no idea how much,
Yeah.
and then it goes to Lyft or this kind of thing. And yeah, I think it's just really, really interesting. And Awesome. So kind of actually, I think, is that, yeah. Okay. So I think that's a pretty good coverage of that kind of topic. Oh, sorry. I just remember. So this separation of recall and archival storage in the
Mm-hmm.
external memory. This is another thing I really wanted to get more insight on is recall storage is like just the buffer of the chat history, whereas external
Yeah,
storage, yeah.
yeah, that's exactly it. So yeah, I also like each of these distinctions. I felt like a little guilty about when I first made them because I don't really think they're necessary. I think like in the eventual the end game of these tool using agents, like these distinctions should be made by the agent.
Hmm.
But the reason I made it was because like to kind of help the agent along, it should be able to query very specifically just the past conversations because that is like in a chatbot setting, like a ton of things you want to do with the chatbot, like look at an old message or look at a message in a time frame. If you're the chatbot or the human, just like think about how often it might not be that often, but probably you do it sometimes. Like going through a messenger or WhatsApp conversation, you're scrolling up or using the search function to find something. That's like what we wanted to give the agent the ability to do. But it's even worse for the agent, right? Because for you and I, like when something leaves the window on WhatsApp, you probably like have it roughly in like short working memory, right?
Hmm.
For the LLM, it's immediately gone. It's like completely vacated its thoughts. So it's even more important to give it the ability to specifically just scroll back through a conversation. And then archival memory was supposed to be just the overflow for like storing general knowledge. So in the paper, we really just tried to keep it as simple as possible. Like, what's the simplest way to just store information that's not important enough to keep in like AK tokens, or not AK, that's the whole thing, but like maybe 2K tokens in the working memory. The simplest thing is probably just a like a text database that has like vector DB indexing or something, and then you retrieve with cosine similarity. And that's basically what we released as like the default implementation. But for a lot of people that want to use MemGPT to like they have their own data they want to bring, you can absolutely just like swap out that archival database and instead you put in your own database and then you tell MemGPT upfront in the first instructions like, hey, just so you know, I connected you to an archival. Your archival database is now holding all the SEC filings or something, or it's now holding all of my email or whatever. Right? So that's very swappable. The recall thing is very specific to just messages or message history only. Yeah.
Yeah, I guess for me, I'm trying to understand the difference between external storage as like a tool, kind of compared to it as this, as it being in its own silo of the diagram with the kind of in context memory. And because I think you could easily think of it as a tool to look at my external storage or just do like a Google search request and then maybe add that to my. That's kind of what I see. Yeah, sorry if I'm going all over the place, but that's kind of what I see as the value of these chatbots having their own private kind of vector database. Is like if they want to do ride sharing earnings research and then they want to store it there so that then it's like kind of more accessible for the future, as like as we have like our personal note taking. That's something I think about a lot, is like I have all these particular notes that you won't find on the web. And so yeah, I guess I'm very curious about this kind of external storage, whether that should be thought of as a tool or, yeah, maybe if we could dive in further on this kind of inspiration from page replacement, like that. I think that's another one of these analogies in the paper that really
Mm-hmm.
captures people's imagination. Can you maybe just from the high level of what inspired you to kind of, compare it with this kind of page replacement and that sort of inspiration?
Yeah, I think so. Page replacement, I think, is a little bit of like a rough analogy with MemGPT because we aren't doing like huge block swaps of like context data in general. It's like very much this rolling buffer that gets it with like an eviction policy. An eviction policy that we implement by default is a recursive summarization, just so that it's like on par at the bare minimum. Like the floor of MemGPT is going to be like a chat GPT kind of thing with recursive summarization on the back.
Hmm.
But yeah, I think a closer analogy, or the one that's like much closer to what actually is implemented in MemGPT, is just like the idea of paginated reads. So like when you take reads from your external data sources, just because of the nature of you being a limited context LLM, so speaking as like the LLM, um, you can never just read an infinite scroll or an infinite stream. You have to paginate it. And paginating it allows you to like have very discrete warnings too, like when you're about to go over the limit. If you just imagine like streaming this to the LLM, you could probably do that, but you would probably run into just like things would start to break down pretty fast. But if you have a very strict pagination system where you only bring in like 1K of context at a time, then you can, as long as like any of your data sources support this pagination format, then you can just connect it to it, right? It's like a kind of a universal interface of just paginated text. So just as long as you can have like a Google search style paginated search over any data source you have, it's just like a universal connector to MemGPT.
Yeah, I definitely want to come back into the search actions, pagination. As you mentioned, like in the paper, you see 8 search results and you say, "Hey, actually, this query wasn't so great." Let me.
Yeah, exactly.
But this kind of page swaps. I'm really interested in this like role playing language models, like multi agent systems, and I think maybe that's where the operating system analogy comes in, where it's like I impersonate Charles, Connor, maybe Shashir, or like Bob, these,
Yeah.
and it's like I'm rotating in and out constantly, this kind of context. And then I can imagine, the kind of like physical memory optimizations that go in where you have kind of like you've brought these personas into, cached memory. And then you're just like, you're now Connor, you're now Charles. And
Yeah.
yeah.
Yeah, that's actually a pretty cool idea. So I think you could so right now the way MemGPT is coded or the prompts are coded, I say like coding and prompting kind of interchangeably at this point, right? But the way the prompt is written is very much about like the agent is also self-aware that its persona is modifiable. So it can like update. That was like a big thing with the initial motivation, which is also these chatbots, like if you're chatting with them for a long period of time, they should change, right? The very basic example is if you just ask the chatbot, what's your favorite color? What's your favorite food? It gives you an answer. You ask it the same thing 100K tokens later, it should return the same answer, right? It's like extremely immersion breaking if it just like doesn't return something that's consistent. And also you do like if you're chatting with a bot for that long, it should really kind of update its own, like it'll have a lot of like depth and detail that it will dump because these language models are so good at just giving convincing text. But that should all be stored and like it develops into a rich personality. So that's a very big part of the prompting in MGPT is telling it that you can modify your own persona and you should actively modify your own persona. But yeah, I think you could definitely expand that to being even more meta where it's like you have a persona bank and you also have a user bank. And when a different user logs in, it will trigger maybe an alert to swap out their user bank. And then the MemGPT itself can see like, oh yeah, Connor logged in. He likes this persona. And then it can hot swap the persona as well. Right?
Yeah, that I think that's just such a powerful idea. This idea, I mean, I had this conversation recently about like the subjectivity of the language model, how it can like, give you kind of like its unique personality in addition to its conversation. And this idea that unique personality is like it's kind of something you add to the prompt and that you can have multiple unique personalities.
Right.
Yeah, it's all pretty I actually think so I think we've done a really great, I think this would be actually a really great transition into, because they're kind of already talking about this like unique personality of chatbots. And in the beginning of the Run LLM podcast with Professor Gonzalez, you described your work and creativity and understanding how AI can, help with creativity and what creative outputs from AI look like. And I think this kind of, new personalities for the chatbots, I think it just would be a really nice transition. So I know it's a pretty open-ended topic, but how are you currently
Yeah.
thinking about it?
Yeah, I guess I would say, yeah. So I think chatbots, they struggle a little bit less with this creativity problem that I described in like the Run LLM podcast because you're constantly having user input, right? Like if you had to generalize this problem, maybe one way to frame it is just when you feed an LM its own content, or when LMs talk to each other, if you've ever played with AutoGen, I think the magic kind of disappears very quickly because you realize like, oh no, like these agents aren't as smart as they are, and it somehow like gives this recursive element to it where you have to feed other agents content, everything just goes downhill. It's like they converge into like this GPT-2-esque behavior where they're all saying a lot but they're not saying anything at all. And yeah, like I said, with chatbots that are interacting with humans, I think you run into this problem less because you have humans that are constantly kind of like interjecting and like bringing like life almost to the conversation. And actually, one thing I did try very early on when I was first messing around with the MemGPT chatbot code was when was working extremely well. I kind of had this idea of like a big part of it was the heartbeats, right? So MemGPT runs in the background, and as a chatbot, that's pretty cool because it'll like see the time. They'll get a little alert of like your heartbeat ran, and it sees the time, and it might say like, "Oh, Charles usually at 3 p.m. is at work, so I shouldn't message him yet. I'm going to sleep my alerts until 5 p.m." And then 5 p.m. comes around, it gets another alert, and it says, "Oh, he's probably home now." I'll send him a little like message saying, "Oh, hey, like how things go? Like remember that project yesterday you talked about? It was really hard." So it's like a very proactive agent because of these heartbeats. And the heartbeats were working so well that I had this idea like, oh, like what if you just run the heartbeats really frequently, and then you have an agent that's always by itself, just like thinking to itself, and it occurs like maybe let's do it like once every 15 minutes. So in reality, I'm not going to talk to the bot that much, and it's going to be talking to itself much more than it's talking to me. And yeah, the exact problem I was describing earlier emerges where like I think my dream was that maybe with GPT-4, it's going to, with enough prompt engineering, come up with like these hobby or like have really cohesive trains of thought where it like thinks really deeply about a book or I don't know, some field of study or like its own hobbies or like existential crisis or something. But in reality, that's like not really what happens. And I really tried to get it to work. So I was trying to emulate like I haven't watched this movie in a while, but her like I think the ending of the movie, like a spoiler, but I think like the bot is like talking to other bots in its own free time or something, and it decides like it doesn't want to be like a user bot anymore. It's something along those lines. So I was kind of wondering like what would happen if I just can I evoke an existential crisis with this bot in its own free time? But yeah, the TLDR is basically I could not get it to work. And it's the same issue with AutoGen, with all these things that feed into each other. The content just kind of really goes downhill pretty quickly. And what I was talking about on the Run LLM podcast was basically more about like an idea for an app that's just fully generated AI content. And I'm sure a lot of people, have had this idea and like are optimistic about it. And I tried to build like a rough version of that, kind of like AI generated games, fully generated games and stories. Like you just give it a little nugget of an idea and it can build out like a fully forking path story, that kind of thing. And yeah, with that, it's a similar issue. Just the content isn't good enough. It's kind of like the uncanny valley of creativity, and it's like, okay, I can see like little sparks here and there, but then you see the same thing over and over again. And then if you try to like apply more pressure to make it more creative by maybe saying, here's a history of all the stories you did, you have to create a new one this time, it still doesn't work. And I think you just run into like a pretty big wall when you try to push these models to really generate creative content on their own. And I'm not sure if I've seen, if anyone listening has had great success with that, please let me know. I'd be really interested to see it.
Yeah, I think for me, like the kind of like graph of thoughts, which I see as like a more extreme version of chain of thought, where you kind of treat like potential continuations of your own thought as like a new node, and you keep going. I feel like all the research on this, and as well as like kind of the community hacking, is just limited by the cost of the inference, and so I don't think we've really gotten to see. And like, I think what you're saying is, probably a lot of people are going like, oh, this sobered me up. Like hearing that talking to each other isn't so effective.
Yeah.
Because I've seen things like at Berkeley's ELO rating for language models, right? Where they talk to each other and then they're evaluated by a third language model, right?
Yeah.
And this is really fascinating stuff. I mean, I guess for me, yeah, that kind of, well, so aside from, I think to just have the, exploration of graph of thoughts, I'm very curious what you think about these kind of like evolutionary perspectives where you maybe have like a population of candidates, and then you sort of, this is like an idea from Jeff Clune and Kenneth Stanley and Joel Lehman, is this idea of like quality diversity. And you kind of have like a population of potential next responses or analysis of or like creative images. Like they had this pick breeder experiment, and so it's like maybe you have a population and you can kind of measure diversity. It's kind of related to like intrinsic motivation. Yeah. I guess this is kind of thinking is I think you need like to have creativity, you need maybe like a population perspective, and then it's like diversity driven, almost like trying to find anomalies or in cluster space.
Yeah. I think it's you maybe could have some luck or some progress, like an evolutionary style approach to it. I think evolutionary algorithms in general kind of do make more sense when when everything becomes a black box API and there's no more gradients. So it becomes useful to just have like evolutionary algorithms or like gradient free ways to pick. Yeah, I don't. I think you could also do more like RLHFE stuff where maybe you just, if it's really content that's meant to be evaluated by humans, maybe there is a way to naturally evaluate it. Like I know some of these, there are like AI bot only Twitter clones and Instagram clones, I think. And yeah, if enough humans are participating and like liking photos or like liking tweets, AI tweets, yeah, that could be a pretty useful data set for like tuning kind of a creative bot. But yeah, I guess my experiments with creativity have really been limited more towards like the biggest closed models like GPT-4, and maybe like some of the largest open models and their fine tunes. I was doing a lot of this work early with Llama 2 fine tunes. But yeah, maybe better luck with Mistral. But yeah, like you said, evolutionary stuff could also help. I would say overall though, I'm a little bit I'm a little bit bearish on the creativity AI stuff. We'll see.
Yeah. Charles, this was such an amazing overview of MemGPT, and thank you so much for answering all these little questions I had. I thought the paper was so well written, and it was so easy for me to kind of, read it and give my analysis because of how, well formulated the ideas are, and these ideas and creativity are so exciting. Maybe let me, if you don't mind answering this kind of anchoring questions on the podcast of like, what's on the horizon, what kind of future directions, just so, I think with creativity, I think this already is so future looking that is, to ask you that is like, you're already telling us what's 5 years, so like what would 10 years then be, I guess?
Yeah, I would say, maybe even just like 1 year away. I do anticipate like a lot of these platform or like more commercial or consumer facing chatbot things to incorporate memory. I think that there's a good reason it hasn't been done yet because it's not entirely clear how to properly do it. I think there's a lot of stuff in open source that experiments with trying to, specifically for more like entertainment chatbots, try to use RAG style thing like vector, like cosine similarity on fragments to get memory to really, it's not really about memory, right? It's more about just immersion and like, can you really bring the immersion of the chatbot that's been chatting with you for a long time into a 8K limit model? And it really hasn't been cracked yet, but I do think that kind of thing will be cracked like independently by like these closed source providers. They'll have their own little implementations of it. It might look like MemGPT, might look a lot more just like smart context, like RAG. And I guess on the API front, I also anticipate like the APIs will probably become stateful too. So you no longer are just doing like your API calls are like all the state you need. It's stateless, right? Because everything for the call is in the package you're sending. The messages, the system, the functions, whatever. Now you're pointing at endpoints of agents that have been like initialized with, they're backed by databases. So I think this general stateful agent, stateful API direction is going to probably emerge in like the next year or so. I mean, I wouldn't be surprised if like OpenAI talks about something like this in a few days. But yeah, I think that's like the very near term. I don't know if you want to talk more about like the long, like 5 years. It's kind of hard to make predictions that far into the future these days.
I'm sorry that the question was too open-ended. That's one of Bob Vinlight, the CEO of Weaviate. He the make the model stateful is one of his big, catchphrases that I've heard so many times. And that kind of, well, I kind of also in the, operating system, I just wanted to maybe like multi-threaded processing with language models. This, like, it's trying to find out what context to add to its memory, and maybe it comes up with like 4 queries and runs them in parallel. Are you thinking a lot about that kind of part of it, of like what, I don't know, maybe like concurrency looks like with these kind of LLM chains?
Yeah, definitely. So I think that's something we're very actively thinking about at Berkeley, and we're actually hoping to kind of build this into MemGPT too. It's a pretty tricky problem. I think it's also tricky in that like the value add of handling all this concurrency does not necessarily immediately show up until you have a ton of data that's just like being thrown
Mhm.
at the bot. Because a lot of things can just naturally be handled synchronously. But yeah, I think also it's another forward-looking trend. I do anticipate a lot of these like LMs will start to look more like OSs. They will have like multi-threaded, or they'll have like asynchronous processes that get spun off of like a single query, and they all like come back. They're all like workers, and they return to the main thread, and the main thread maybe runs on some cycle, kind of like similar to CPU, or it's like it's like event driven, or like or both, like cycle and event driven, and yeah, I think that definitely is also just like the future. And I mean, it also fits into this smaller model trend we're seeing right now. It might be like a
Mhm.
micro trend, right? It's kind of hard to evaluate like what's a micro trend, what's a macro trend. But I do kind of maybe see, yeah, it's hard to say, but like maybe if GPT-4 performance to a certain degree is like kind of plateauing, and now the value adds are coming from the different like integrations, that maybe then will signal models getting smaller, to a certain extent, right? Everything gets compressed down. And yeah,
Mhm.
like I said, I've been super impressed by like some of these 7B models. Like I'm pretty shocked at how good they are. And they are pretty, they make me, they're pretty promising, I think. So I would not be surprised if like the trend is smaller models running in parallel, OS style, like you said.
Yeah, it's amazing. I mean, the ability of that to enable MemGPT style processing, as well as I think that kind of creativity thing, is also kind of waiting on the smaller models that are cheaper,
Yeah.
faster, and yeah, amazing. Charles, thank you so much for joining the Weaviate podcast. It was such an insightful discussion, and just massive congratulations on MemGPT. I think it's an enormous contribution to people thinking about RAG and LLM agents and tool use and all this exciting stuff. Thanks again.
Awesome. Thanks for having me.